Today we're going to talk about piecewise and step functions. Those are exactly as you think they are. A piecewise function is chunks or pieces of different functions on one coordinate graph. A step function is essentially looks like a graph that has stairs on it. It looks like a stair-stepping, graph. So that's what that is. So we're going to talk about those two graphs today. The big component of those two graphs are what the domain happens to be, what our inputs are, where we're at with these different, what they call intervals. So if I take a look at this here from mathisfun.com, we're talking about piecewise functions on one particular graph. So we could take different functions on one graph, and it all gives us lots of information. It all makes a big difference as to what our domain happens to be. Our domain is our x. So in this case here, the function x specifically between this interval, and the function x specifically between this interval, and the function x specifically between this interval here. It's going down between these guys here. So if I write that, that's what the function actually is. So now let's say, for example, I take a look at this graph right here. If I'm looking at this graph right here, boy, there's a lot going on. Look at this graph right here. This is a parabola, y equals x squared. But it stops, if you'll notice, it stops at x is equal to 2. So here I got 1, 2. So x is at 2. It doesn't equal that, but it stops here. So open circles, I'm not including it in my answer. But as my x goes to negative infinity, this will still go up. This is continuous. It's not, there's no dots. That's why it's very insistent that you have arrows at the end of your lines. So as I'm going through here, it's just saying my x will go on to negative infinity. As such, this graph will continue. In this case here, however, my x is only at 2, but my y is at 6. So this particular function, this graph right here, this part, that's just 1 point. I have a third function on here. Again, they don't have to be linear functions, just functions on this particular graph. I have a third one here at this where x is equal to 2 through 6. This is what's happening here. This is the function here, y equals 10 minus x. This graph is going down, and as I see, it's between this specific set of domain values, it's going down. It's open circle here, closed circles here, and then we're done. So it's very specific. This is why I had you graph the way I had you do it. Now, let's go a little bit further. If I were to write it, it looks something scary like that. So here I'm saying that this is the function. Oh my God, right? This is the function. F of x equals, now these three different functions are all in here, x squared for values that are 2 and less. It's at less than 2. For x values that are less than 2, 1.99999 and less, going to negative infinity, it looks like this. If I have a value of 2, it's exactly 6. If I have a value that's greater than 2, but less than and equal to 6, this is what I'm going to use. So it all depends on what happens to the graph, depends on what my input is. So say I have the input for 7, I go 7, where does 7 fit? 7 goes here. This is going to happen. If I have an input, say, of negative 10, where does negative 10 go? Not there, not right here. So this is a function that applies for negative 10. So what function we use, or what part of the function we use, all is dependent upon the domain. So let's take a look at our actual notes over here. Okay, I'm going back to the Cami. Not in trouble, though. Trial ends in 16 days. All right, here we go. So when we're taking a look at our chunked up piecewise linear function, okay, we have to look at the different pieces. So take a look at this example 1. That gives 2x plus 4 for our x values, the domain value is less than a negative 1, okay? Sorry, less than or equal to a positive 1. And then for values that are greater than 1, this is what we're going to use, okay? So I want you to graph this part first, and here's how you graph it, okay? And this looks kind of confusing. Hang on one second. And I really should be using my webcam, but I don't have that here at home, so sorry, guys. So this is my horrible graph without a ruler. I need to use a ruler. Okay, so I have 2x plus 4, and x is less than or equal to 1. I have it at 0, 4, and then I went up 2 and right 1. My slope is 2 over 1, so I went up 2 and right 1. Okay, but here's the caveat with this graph. I can only have values that are at 1, x equal to 1, or less than that. So now I'm going to go up here, find 1. All right, there's my point right there. I'm going to change the colors so you can see this a little bit better. Now, I only want to have the graph where my x values are going like this. I need to go like that. Okay. Now, when you go to graph it, okay, when you go to graph it, then erase. No, yeah, that's fine. Erase what isn't included in the domain. So, for example, here I have x is less than or equal to 1. Then here's my x at 1, I think. Why is this being so ornery? X at 1. Oh my God. And as I'm going this direction here, you'll see I have all of, hang on, x is at 1, but I'm going to the negative value, so it's negative infinity, so it's going that way. So I'll include the graph that includes all my x values through here. So what I'd like to do for me is I graph the line as it should be normally, but then I go ahead and erase the graph. So if you'll remember, I had this up here like, why isn't that highlighter working? It's so stupid. You should be working, stupid highlighter. I had all that there, but I erased it because it said only those domain values that are less than 1. So go ahead. I'm not going to suffer through it. Oh, they have the answer right there. And I want you to graph that. Let's see what they did. Blah, blah, blah. Okay, blah, blah, blah. So now, if I take a look at this, the key is we have to know what our domain and our range is. So right now, I want you to write down what you think the domain and range is. Well, the domain's all real numbers. Where's your range going to be at? Where's our range going to be at? Hopefully you notice the range is, here's my y values, it's my range. So this is 1, 2, 3, 4, 5, 6. The range is going to be 6 and down, okay? So if I'm looking at my range, I can't have anything higher than 6, so my graph doesn't go higher than 6, so it's 6 and down. Now here's a questionable part right here at 2, and if you'll notice when x is at 2, it doesn't really matter because I have the open dot right here and the closed dot. So since this is open here, this is closed here, that takes care of that particular number. Because at where I'm at my range is at 2, even though when x is 1, 2 is not included, but when x is a negative 1, 2 is certainly included. Okay, that's important to note. Moving right along. Go ahead and do the check. Do the check and make sure you answer the question in the Edpuzzle. I was going to do the next section, which is stepwise functions, but we're not going to do step functions at all here. We'll do it in another video. So that is the phrase that pays. We'll do it tomorrow. We'll do it tomorrow.